Okay, so first of all, I said yesterday, if you haven't screenshotted the slide that has all the law of cosines formulas on it, I would definitely recommend that because obviously that's something that should go on your reference sheet. So this one says use the law of cosines to solve the triangle rounded 2 decimal places. Remember, it's not going to tell you which of the formulas to use. It's just going to say solve the triangle by the time we get to quiz. So you want to know that side, 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 and side angle side, which means one of each letter. You're going to use law of cosines, but then everything else you're going to use law of sines. So that's probably the easiest way to remember it. So for the first one, this is our side, side, side. And yesterday I said you can find the first one using law of cosines and then switch. But if you're going to use that method, what do you have to do?
You have to find the biggest one first.
You have to find the biggest one first. Good. If you just find them all using law, or the first two using law of cosines and the last one 180 minus the other two, then the order doesn't matter. But if you're going to switch, you have to use the big one first, which means you'd solve for B. So I'm just going to do that out of like just sheer, like that's how I always start. Okay, I'm just going to do that first. So I'll do cosine of B equals, and then it's the other 2 squared. So A squared plus C squared minus B squared over 2AC. And then I'm going to do all of that in the calculator. So I'm going to cosine -1, that whole thing. And again, remember, you have to put the numerator and the denominator in parentheses so that you tell it what order to do this and it doesn't follow order of operations. So from here, I get angle B is 34.047. So it's 34.05 degrees. So that's the first. I'm going to need angle A, I'm going to need angle B, and I'm going to need angle C. These will all be fill in the blank. They won't include the degree symbol. You'll just give me the value. They're all going to be rounded to 2 decimal places, so you can like start practicing all that stuff. All right, then I go to angle A, let's say. And again, it wouldn't matter if I was in law of cosines, the order, but if you switch to law of sines, that does matter. So if I did cosine A, then I'm going to do B squared, 10 squared, plus C squared, 15 squared, minus A squared, 7 squared, over 2 times 10 times 15. And I'm going to do that all in one step, grouping my numerator and my denominator. Oops. Two times 10 times 15. And I get that angle A is 77.29 degrees. Uh-huh.
What are you doing on the right side?
The blue?
Yeah, the blue.
That's to find A. I'm just writing the answers on the left.
Oh.
Yeah. And then the last one we've got to find is angle C. And for this one, I can subtract it from 180. So 180 minus 34.04 minus 77.29. And you get 68.66 degrees. And then again, like I said yesterday, I would say with extra time, I would go back and I would do angle C using law of cosines and see if it's the same. It might be a little off with the rounding. It might be like 100th off, but it should be pretty darn close. Questions on that one? Okay, then comes 2, which is side angle side. I know that because I have one angle and I have one of each letter. So side angle side, I have to find first the missing side, and then I can find the rest of the angles. So my missing side is side A. So I would do A squared equals B squared plus C squared minus 2BC cosine, make sure you do cosine, A. So B squared is 4, C is 9, 2 times 4 times 9, times the cosine of my angle, which is 135. 4 squared plus 9 squared minus 2 times 4 times 9 times the cosine of 135. And I get 147.91. Don't forget to square root that. That is a mistake people make. So I square root this whole thing, and I get A equals 12.16. So we didn't have to use any rounded values with number 1. You would have if you switched to law of sines, but you don't if you keep it as law of cosines. With side angle side, you have no choice. You're going to have to use, whether you switch to law of sines or you keep it as law of cosines, you'll always use a rounded value. So don't stress too much about that. You can't avoid it. All right, so now I need to find angle B, and then I need to find angle C. So I'm going to find B. Again, I'll just practice with law of cosine since we're in that section. Angle cosine of B would be a squared plus c squared minus b squared over 2ac. So this is 12.16 squared plus 9 squared minus 4 squared over 2 times 12.16 times 9. And then I second cosine that whole thing. And I get angle B is 13.46. And then I can find angle C by subtracting A and B from 180. So 180 minus 135 minus 13.46. And I get 31.54. You could also do cosine of A on that last angle, cosine of C, on that last angle to check that as well. But again, I would wait until you have extra time at the end of your quiz. Questions on either of those? We're good so far? Yes? Okay, so we left off, this is obviously the formulas. I would say, if you haven't screenshot that screen, I would do it. We left off with this word problem, right? And yours? Oh, you guys. All right, so this one says, if you're on island B, what bearing should you navigate to go to island C? So if we're starting at B and we want to go to C, the first thing we have to figure out is direction, north or south, and then east or west. So because I'm starting at B and I want to go to island C, that would bring me north, right? And then I want to turn left, which means west. Now I've got to find this angle measurement in here, which is this angle measurement there. This is a law of cosines problem. I have all 3 sides, so hopefully that's easy to identify. But in law of cosines, we use it to find the angles inside the triangle. So if I find angle B inside the triangle, I can simply subtract it from 90 because these would be perpendicular to find the angle outside the triangle, which is what we're looking for. So I'm going to say the cosine of B equals, and it doesn't matter the letters really, it's the 2 sides that are next to it. So 23 squared plus 22 squared minus the one opposite it over 2 times those first 2. So I get second cosine, group it, 23 squared plus 22 squared minus 16 squared. Close my parentheses, divided by, open them up again. And I get angle B is 41.58 degrees. But again, that's what's inside the triangle. So we want to subtract it from 90 to get what's outside, which is 48 it didn't tell you what to round to, so I'm going to keep it at 2 degrees. The quiz will tell you what to round to. And again, on the quiz, the word problems are going to get mixed together. So it's up to you to figure out, is this word problem solved using law of sines or law of cosines? And again, if it's law of cosines, it's side, 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 it's side, angle, side, and then anything else is going to be law of sines. All right, so we left off on the last formula for area, which is Herons Formula. So Herons Formula allows you to find the area of a triangle knowing all 3 sides. So I know nothing about the height, I know nothing about any of the angles, but I have the lengths of all 3 sides. The formula for Herons is the square root of s times s times a, s minus a times s minus b times s minus c. And we find s by adding the 3 sides and dividing by 2. So be careful, that's not the average. We're not dividing by 3, we're dividing by 2. So the first thing you're going to do is add up the 3 sides, divide by 2, and that gives you your s. And then I set up my equation. The biggest thing, this should be easy, especially if you have the formula. The biggest thing here is you do not round s. So S will terminate at some point. Sometimes it's 1 decimal, sometimes it's 2, sometimes it's 3, but we're cutting it in half. It will always terminate at some point. You have to keep the entire decimal. So if there's 3 digits behind the decimal place, you have to have all 3 every time. You do not round S. The answer that will be marked correct on Canvas will be if you do not round S. If you round S, it's not right. All right, so it looks like this. Find the area of the triangle with the given side lengths. A is 5, B is 7, C is 10. So the first thing I'm going to do is find S. 5 plus 7 plus 10 over 2. 22 over 2, which is 11.5. 11. Holy moly, it's just 11. Then I get my area. Square root of 11 times 11 minus 5 times 11 minus 7 times 11 minus 10. Now you can simplify what's inside those parentheses, and it's pretty easy when they're nice whole numbers, but you also can type that entire thing into your calculator. So I can rewrite it as 11 times 6 times 4 times 1, or you literally can write that whole thing in your calculator. The square root of 11, open the parentheses, 11 minus 5, close the parentheses, open the parentheses, 11 minus 7, close the parentheses, open the parentheses, 11 minus 10, close the parentheses, hit enter, and I get my area is 16.248. So I didn't give it to you, but if it tells you to round to 2 decimal places, it would be 16.25. So you will round at the end, you just can't round S in the process. This time it didn't matter, S was a whole number, but it won't always be that way. All right, you do B.
Miss Chris, why is S always gonna be greater than like all the side lengths?
Not all of them, no, because one could be huge, which pulls up the other two, like the average. Does that make sense? Let me think. Dividing by 2, it might always, unless one is really long, and then they can't be that different. So I don't know the answer to that question. I actually think you might be right. Yeah.
Doesn't S always have to be positive?
It's always positive. No, she said it would always be bigger than all 3 sides.
If it's negative, then.
Something's wrong.
But I'm saying if it was smaller, wouldn't it go negative, and then you have a negative under the 3?
No, smaller than all 3. Like, so that it could be, bigger than all 3. It could be bigger than 2 of them. Does that make sense?
Like, okay, so if let's say, like, for this one we have, like 2.4, right?
S will always be bigger than them. Otherwise, it would result in a negative underneath the square root, which would result in a negative, the square root of a negative number, which can't happen. So yes, S will always be bigger than each side. 0. I've never had that question before. 3.125 minus 2.45. Okay, so I would add them all together, divide by 2, and I get 3.125, and then this is exactly what I would type in my calculator. The square root of 3.125, 3.125 minus 3.05, 3.125 minus 0.75, 3.125 minus 2.45, and my area is 0.612. And that's the area of the triangle, God bless you, formed by those 2 sides. So it takes longer to type it in your calculator than does anything else. These should be super easy. Just, I will tell you, every year somebody rounds S. Do not do that. Questions on anything law of cosine related? Questions that came up on the homework? If you started it yesterday?
This I don't get one of the homework problems.
Okay, which one? A 100-foot vertical tower is to be erected on the side of a hill that makes a 6-degree angle with the horizontal. So there's that slope on the horizontal again. So when you draw this out, because again, remember, you could do it without having, well, you will have to draw it out. If I had a tower, the horizontal is obviously the 90. But if there's a slope on that horizontal, that's 6 degrees. I could put it here, I could put it here. That's going to, hang on. Wait for it. Look, no hands. I'm a magician. Wait for it. Wait for it. Wait for it. There we go. So that slope can either be on the left side or it could be on the right side. Okay, it doesn't matter where you put it. Those are vertical angles. It's always going to have the same impact. It says that the tower itself is 110 feet. And it says to find the length of the 2 guy wires that would be anchored 75 feet uphill and downhill from the base of the tower. So a guy wire, which is usually in word problems and throws people off, is just a wire. Okay, it's a wire that's tied to the top of something and then it's tied down. So this is one wire. Again, wait for it, wait for it. Let me pause it. All right, so the blue one on the right is one of the wires, and then you'd have another one going the other way. And it says that they are, 75 feet uphill, so this would be 75 and 75 feet downhill. So you basically have 2 separate triangles here, one on this side and one on this side. You want to find X and you want to find Y because you want to find the length of both of those wires. So if I look at the triangles I just drew, on the one on the left, that 6-degree angle is going to get added on to the 90 degrees, right? Because we said this angle, the little angle in here, this sloped angle would be 6 degrees. So this would be 96 degrees. And it's going to be subtracted from the one on the right, so 90 minus 6. 84 degrees. Those two together should make 180, so that makes sense. Then over here, like this angle here, is the same as this angle. It's the one that's 84 because it would be 90 minus the 6. Those are also corresponding. And this angle over here would be the same as the 96 because it would be the 90 plus the 6 degrees, or the 96 is because they're corresponding. You with me so far?
Yeah, now I'm trying to get it.
Okay, good. So then it's side angle side. This is the side you don't have. These are the sides you do have, and then that's the angle in between.
Alright, so just do like a side angle side problem.
Yep. And 84 is the angle. 84 is the angle on the right triangle. So on X, 84 is the angle. And then on the Y, 96 is the angle. You're welcome.
Well, I also have another one.
Okay.
On number 4, I don't know how to do that one.
All right, so here you're dealing with a parallelogram, okay, which again, like skills, you need a lot of skills from geometry in this section because it brings back your parallel lines in the last section too. And it brings back things like properties of a parallelogram. So this is a parallelogram, right? And it gives you, in your case, your side lengths were 21 and then 45. And then it said, complete the table, solving the parallelogram shown in the figure, blah, 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 blah. So it wants you to find the diagonal, the lengths, and it gives you, the only other thing it gives you is the angle, which is where? Did I cut that off? That doesn't match the angle.
Yeah, that's why I was confused.
That doesn't match the same symbol. Yeah. Hang on, let me see where, because you're missing theta. Okay, so this should be this angle up here. So this is the 128. So from there, there's a couple of things, again, you got to know about a parallelogram. One is that the opposite sides are congruent. So this is 45 and this is 21. The other is that this C is the whole diagonal. So it's not just part of the diagonal. The diagonals do bisect each other. So if the C was just half of the diagonal, I would just cut it in half. That's the other thing, hopefully you remember about parallelograms. These are congruent and these are congruent. So when we do the quiz review, I'll give you another, like a really it's a pretty common question where it will give you the lengths of the diagonals, and you have to find the sides of the parabola, for the sides of the parallelogram. And for that, I'll give you the lengths of the diagonals, and I'll give you an angle where they meet, and you have to know that the diagonals bisect each other. So that's a question on the quiz review, but you'll see it tomorrow. But just know that that's also a property of a parallelogram. Diagonals bisect each other. But now it's just a side angle side problem using that 128. Does that make sense?
Yeah, I get you. And then like also like the one on the bottom left is 128.
No. The one on the bottom right is 128. Opposite angles are congruent in the parallelogram. The consecutive, which is what you're talking about, are supplementary. So I'd have to do 180 minus the 128, or 52, and that's this angle.
Oh, okay.
All
I
the
get it now, thank you.
Yeah, you're welcome. All the things that they assume you know, and that, like, parallelograms are big on standardized tests, so it's good to review those skills. But they will assume that you know all the things about parallelograms.